Mohsen Marafat, and I thank you for your time. I would like to give you a quick introduction to a company that I'm a co-founder of. We're very excited about the company, its products, its partnerships with the major industry players, and the fast-growing economic sectors that we're going to be serving. The company is called PowerSensAI. Power is electrical energy over time. And SenseAI represents the technology that we are bringing to the market, intelligent sensors powered by artificial intelligence algorithms that allow us to do safety and reliability systems at a very, very competitive cost. These are unprecedented because the industry is very new with power devices that didn't exist a few years ago, and yet we have situations where manufacturers have to warranty systems for long term. The reliability monitoring and safety markets are huge for this. Not many people have solutions. So the solutions that we're bringing to this market are unprecedented. Requires devices like the one you see on the left here is a typical power converter. Very shortly, these devices are shrinking. It requires less material. And that tower thingy that you see represents a heat sink. That's wasted energy that you have to somehow manage and get rid of. And that also will go down. So these systems will become smaller, less material, cheaper, easier, for portability and also for reliability, as well as the fact that you're wasting less and less energy in doing whatever conversion that you have to do, okay? Now, we are a critical player in this because as the energy becomes more dense, more energy in a small space, become faster, the control, safety, and reliability of these become trickier. And that's what we have spent the last 7 years on developing both components and systems that are critical to the efficient operation of these kinds of systems. A quick introduction for the two founders. Babak is a well-recognized guru of power electronics. He is not only well-known in academia, as you can see, he's been very much involved in the professional societies of electrical engineers. He's also a hands-on engineer that has done many contracts with major electrical equipment companies, including most recently a research project that he is finishing at Tesla in Palo Alto, the research center. We'll talk about that a little bit. I've been around a little bit longer than Babak, and I have been always involved in power engineering. And over time, I've been involved with a lot of innovations, including for the first time combining a lot of power transistors into one chip that allowed us to make a low-cost power controller, and that device is now the de facto standard. I've kept my hands in the power engineering as well as also consulting with companies and high-tech businesses, including work that I've done for holding companies and financial feasibility studies, as well as startup consulting with companies that are adjacent to my field, but like medical diagnostics, partnerships that we're involved with right now, where our inventions and devices are being pulled into what they're doing out of necessity for them. And it's a pleasure for us to help them get that done. So the first one is this major energy transformation. You see this as a traditional coal power plant. Trains come in with coal, you convert it to heat. Heat runs turbines produce electricity, it goes on a subsystem, goes on the grid. And all these offices up front indicate that there's a lot of people involved in doing this. And the chimneys, if you're lucky, you're just blowing off steam here. But we know that even the best of the power plants have emissions and CO2 and as well as some pollutants. So what happens if I take this system and convert it to this? Basically a trailer park of batteries. These batteries can collect energy from solar panels, from wind power, or from the grid itself and give it back to the grid when it's needed. And this utility scale electrical power storage is an industry that did not exist a year ago. In 2023, if you talk to people that say, well, that's going to take some time. But right now, just a few months ago, back in April, Tesla sold one of these energy storage systems into Hawaii utilities, and they replaced the coal power plant with it. A lot of other people are involved in this. This is the fastest thing that is happening in the energy world. And as you see in the corner here, there's power electronics converting the battery power to grid, or taking the grid and converting it to storage on these batteries. That's where we are. We are in this little box. And what we're helping Tesla with, and we've done the feasibility study for this project, first with Department of Energy and most recently at Tesla's Palo Alto Research Center, where we're showing them that we can have systems that predictively look at the reliability of the power conversion. Basically, if it's an existing facility, we have a handheld device that the service personnel can use to get green, yellow, red. Red means replace the power panels. Yellow means you have a certain amount of time to do it. Green means you're okay. Now, the significance to this is that when Tesla sells a power pack, what they call a mega pack, Tesla or anybody else in this industry, to utilities are regulated, and they have to have long-term warranties on these systems. They have to have a clear picture of the reliability. And at the moment, the industry is very new, very fast with deploying new power transistors, and they don't have any standardized reliability systems. We hope to be that system for everybody, starting with our partner in Palo Alto. And what our devices do, either as a field service or as a built-in device, represents a huge financial opportunity. These mega packs replacing power plants is a $1 trillion business. I think our opportunity there is in the billions of dollars. And how quickly we can jump on that remains to be seen. But to go into all of the existing installations and then be built in the future ones is a good portion of our plan. There is another major industry demand that we're responding to, and that is has to do with the electric cars. EVs have been successful. They're going to go through ebbs and flows in terms of their economic development and getting adopted by various consumers and industrial sectors. We're seeing EVs going into agriculture and heavy equipment like mining equipment. But they all have this in common where they need to be charged. If they have batteries, you need to charge them. The charging machinery is one of the major issues, because if you look at this graph, it shows you gas station installations in the country versus chargers. And charging takes a little bit longer than filling up your car with gas at the moment. And so that's the challenge that needs to be addressed. So the industry has developed better and better chargers. We have been involved with some of that work. But the major challenge is electrical systems in the cars themselves, for one thing, to prevent short circuits and detect overcurrent situations so that you can protect the battery pack in the car. And right now we're involved with a company called Littelfuse. It's a 100-year-old company, prominent in the automotive industry. All the existing fuses in the cars, existing old cars, are Littelfuse, and but they're also seeing this challenge. So they're involved with creating a circuit breaker that is made out of transistors, so a solid-state circuit breaker. And they need sensors to detect conditions such as short circuit and overcurrent. They have actually started, Littelfuse themselves has sensors of that sort. They've started with their own, and then they've looked at whatever else is available in the industry that can meet their size and power consumption and pricing restrictions, and yet they need to be fast enough to do this job before there's any damage. Well, I was just in the research lab in Spain, and the team that is designing the circuit breaker likes our device better than their own and other devices available in the market, in short. We have a few months of development left in there, but their circuit breaker is projected to have volumes of 500,000 initially per year, but very quickly to several million a year. They're at, they have major automotive customers that are demanding this. And we could have 1 or 2 sensors per circuit breaker. Their work goes well, and we're very much involved in helping them. So that's an economic opportunity that is sizable for us. The other major development that is changing our society is the data centers. They're getting more and more powerful. Their demand on them for running zeros and ones is highly accelerating due to developments such as cryptocurrency and now AI. AI algorithms require these processors that are much bigger than the old Intel and AMD processors used in the servers. But now the data centers have to handle a lot more power. They are getting restricted at the same time as they have a major economic opportunity. They are getting restricted by the localities they're in because of the power usage. So they need to go to a new generation of power, be more efficient, waste less power. All of this goes back to the principles of power electronics that we're involved with, as well as protection. Again, higher power densities require more and more protection and reliability. So this is another major opportunity. We have already shown that feasibility in a project we did with NASA, but it's a brand new product. Nobody else has it. So this is our spike guard that can help the data center industry. Let me add one more thing. We're also working with a potential manufacturing partner. One of their economic sectors is they build data centers, and they're very interested in everything I just told you. Just to tell you a quick background of how we got here, the company went through phases of basically academic development. Then we started a company called Telai Technologies in North Carolina, which is referred to as a tech transfer company. This allowed us to bring the academic material, actually build devices, prove the feasibility. We did a lot of projects with places like NASA, Department of Energy, National Science Foundation, and within these projects that are, you get a lot of scrutiny and peer review. We got devices ready and we started putting them on catalogs that engineers use for development. And that gave us a lot of insight into the industry. You see some of these pictures of the Telai devices that are available. Next to the competition, they shine. They lead the market. You can't see the sizing here, but like this device is larger than my fist, whereas these are small chips. Our devices do not consume power like these guys do. They are isolated by their technology from the high power that is going through the converter. And these guys need typically to add additional circuitry to get the isolation. And they're smaller, ultimately will be cheaper to deploy than any of the older technologies. We do have competition in this area. By partnering with the right people, we think we can get to market very quickly. I thank you for listening to this discussion. We invite you to come and talk to us. We would very much like to find out how much financial opportunity is there for us to build and scale the company. We can go one by one on these opportunities, but technology-wise, we can address multiple sectors at the same time, and we can develop these partnerships better and faster. And we would very much like to hear your ideas about doing so. Thank you, and I look forward to speaking with you.